Suppose that $15,000 is invested at 5% annual interest compounded continuously. How much will be in the account in 5 years if no money is withdrawn? So I've written the important information down. The principal is $15,000, the interest rate 5%, and the time is 5 years. We'll use the formula that the amount in the account is equal to the principal times e raised to the RT. And we substitute in A is equal to, and P is the 15,000, E is itself, R is 5%, which we write as 0.05 times T, which is 5. And that will give us that A is approximately equal to 15,000 times, and you get a decimal that goes on forever. I'll give you a certain amount of those digits. It's 1.2840254,166. And that's why I say it's approximately equal to that. And then, using a calculator to evaluate this, we find out that A is approximately 19,260.38. And what that means is there will be $19,260.38 in the account in 5 years if no money is withdrawn. Suppose that $15,000 is invested at 5% annual interest compounded continuously. How long, to the nearest tenth of a year, will it take for the initial principal to double? So we know that the initial principal is $15,000. We want to know when that is doubled. In other words, $30,000 would replace the value of A. 15,000 replaces the value of P. E is itself. R, which is 5%, as a decimal, 0.05, and then times T, and T is the variable that we want to solve for, which would be the time that it takes for it to double. Now, dividing both sides by 15,000, of course, this becomes 1, this becomes 2. So what we have is 2 equals E raised to the 0.05 T. Since T is in the exponent, we need to take the log of both sides in order to be able to take T out of the exponent. We'll use the natural log, so the natural log of 2 is equal to the natural log of E raised to the 0.05 T. Now, of course, on the right-hand side, that all simplifies to 0.05 T. And so now to isolate T, we simply divide both sides by 0.05. I'm going to write the T first, so T will equal the natural log of 2 divided by 0.05. If you use a calculator to evaluate that, it's approximately equal to 13.86294, and it keeps going. We were asked to round it to the nearest tenth, and so that's why I can stop here, because here's the tenth. We only need to look at the 6, which is 5 or greater, so we add 1 to the 8, so it's approximately 13.9. And that means that our answer is that the initial principal will double in about 13.9 years.